The building industry globally is a $10 trillion business a year. There was an Economist article published about 2 years ago about our industry, and not in a very kind way. It basically said it's the only industry in the world that has seen negative productivity gains in the last 50 years. The only industry. So keep that in context of what we're doing. In North America, they've basically seen productivity in the building industry decrease by almost half. If you look at any other business, they're all striving for productivity gains. And why we in the building industry, and they give a number of different reasons. What they did ultimately is they compared the building industry today. If you were to look at where we are and where we should be, we're in the Walkman stage as opposed to the iPhone stage. That's how far behind we are. And part of that problem is we're so resistant to change that adopting new technologies, whether it be AI or anything that comes onto the market that's new, the industry has a really, really hard time. And I think that indication here is pretty evident. SIPs are essentially an EPS styrofoam that has an OSB skin on both the inside and the outside. It's laminated together. We can produce them in 8 feet by 24 feet long. They can be cut to suit whatever sizes are needed. They're engineered. You have chases in the actual cavity, so you can run all of your electrical. You can cut all your openings quickly and easy. I'm going to skip through the basics just because so many of you put your hand up in terms of knowing what SIPs are. The real goal of all of this is to create a high-performance, low-leakage environment, or a low-leakage envelope, And we can do it all the way from the basement with a pressure-treated product, so we no longer use concrete, and you no longer have to insulate the inside of it, which is a mandatory in basements today in residences, all the way up to the roof, which we can produce 14 and a quarter inch panels to give you upwards of R60 rating. And the whole idea is that you've now got a building envelope that shouldn't have, our target typically is less than 1 ACH for that building envelope. The target for passive homes is 0.6. So if we really do this well, in some cases we have been able to get ourselves to 0.6 ACH, which is something that we're all striving for. One of the big advantages as well of this is there's basically zero site waste. So you're not removing any site materials or waste once you're doing this. It goes together like Lego blocks. We have done homes with this. Typically a framer will take up to 3 weeks to do. We'll have it done in 4 days. These are all just part of that mechanics of trying to get people to become more efficient, less wasteful. The product itself is environmentally friendly. It's quite good that way. As I mentioned, energy savings on this, if it's done properly, we're seeing 50 to 60% lower energy costs in a home. We're actually toying with a program right now where we'll go with builders, partner up with them, and we'll pay the end consumer who purchases their home to pay for their utility bills for 1 year. It's a bit of a double-edged sword in that somebody's not going to care about their energy consumption at that point, but we're hoping that people actually take it responsibly as opposed to just take advantage of it. So, as I mentioned, we can literally reduce construction waste by up to 30% by using these panels. We have used these panels in situations where we can actually do the entire interior walls and exterior walls. We do a fair number of homes right now for First Nations that need the durability as well. So durability becomes a huge issue here. In terms of where the envelope itself or the building itself, it can withstand literally hurricane winds. There's been examples down in Florida where the only building standing in an area is the one SIP home that happens to be built in that area. Our biggest challenge is getting people to make change, and I think that's an industry-wide problem. One thing that was on that last slide, for those that are trying to do LEEDs, you get upwards of 34 points on your LEED accreditation using this particular product. And of course, it obviously depends on the particular application. That's a pretty high number considering that I believe silver is 50 points to get a silver LEED certification. So this can be a great contributor to anybody that's out there trying to get that LEED certification. We've done some homes, EnerGuide ratings. There's still a number of systems out there. EnerGuide, I think, is still a valid one. We've done homes that have run as high as 87 on the EnerGuide rating, just because of not just because of the SIP speeds. We also tend to incorporate a lot of other items into the built environment that help this. Hot water on demand helps those things. But the fact that the SIP panel is so tight and creates such a great envelope, we know that that's a huge contributor to the overall EnerGuide rating that buildings built with this product achieve. I think for most people in this room, you're probably quite familiar with where this is. Our target is typically anything over 85 in an EnerGuide rating. We also build homes. We have a plant here in Red Deer, for those of you that don't know that, and we have a show home there. It's basically 580 square feet. In the coldest month of the year, we didn't spend $28 to heat this home 24/7 at 21 degrees. So that just tells you the type of performance that this product can give you. These, again, are just some typical R values, because we can put these together anywhere from 4.5 inches to, on here we have only to 12 and an eighth, but it's actually, we can go up to 14 and a quarter now. And it's really just the difference in the EPS that goes into the middle. Thermal bridging, obviously. This is probably an extreme example, because we still do use lumber in a SIP panel product, but it's nowhere near what a traditional stick built would be. This is actually a photograph of our plant, which was done with a SIP panel skin. All the walls and roof were done this way. It's 23,000 square feet, and the reason I have it up there is our most expensive heating bill for 23,000 square feet was $550 a month. One of the reasons that we really like this is we eliminate a few steps in the actual construction process. Typically, we can also get away with without using drywall, unless there's a fire code issue where we have to use Type X, but we can actually put an orange peel on top of the OSB and finish the entire inside of the building, which is just one less step that has to be dealt with. So this is about efficiencies. This is about being able to figure out how to use this product in a way that it's intended to be used. It's a little bit of a disruptor. I've got some clients that essentially say, well, if I can do this differently, and I can schedule everything so that the day that envelope is up, I've got windows and doors in there, and I can close up a building in 2 weeks. And now my plumber and my electrician don't have to work in a cold building until it's roughing in and doing all that stuff. They're going to go to our product before they go to somebody in the middle of winter. We all know what that's like. And on top of that, typically once they've used it once or twice, an electrician will save up to 30% of his time just in install for this type of product. So there's huge advantages, but it goes back to my opening statement, which is we're a $10 trillion industry, but we've not seen any efficiencies or productivity gains in the industry. Is we're not thinking outside of the box and allowing ourselves to do it differently. We're stuck in sort of systems that are in place today, and we deal with this every day. It's like, well, yeah, we like that product, but this is the way we do it, and we're not going to change. This group, as a green building group, needs to be able to push that envelope and be able to allow this type of stuff to be adopted by the industry as a whole. There's a great organization called SEPA, which is a nonprofit organization run out of the U.S. It's called SIPS.org. If you want to go onto their website, they have tremendous information on there for anybody that wants to. Our website has lots too, but they do quite a good job. Their challenge, again, is convincing the industry. We had a conference about 3 weeks ago, and what the building industry is saying, we love the product, but we don't know how to use it. And so part of our challenge is teaching everyone both the benefit and how to actually implement it into your construction process and make that construction process more effective and more efficient for you. We can typically see 50% reduction in just construction times on projects using this and a whole bunch of other products if they're just willing to step outside the box and do it. This just gives you a bit of an idea. I mean, smaller crews, it's not complicated to do. We give training courses for anybody that wants them, but literally within a couple of hours they tell you to just get out of my way, I got it figured out, and they're off and running. This is a typical example of a foundation wall where we were using pressure-treated plywood. Again, the 1 to 2 days versus the typical traditional cribbing. You've still got to finish the outsides. You've still got to tar it. You've still got to put a bubble wrap around it. You've still got to put all your other things. But the actual foundation wall now is insulated. You no longer have to go in, fur it out, and insulate and vapor barrier it just to meet the code requirements. It's already part of the package. This project literally took 3 weeks to do the exterior skin and the roof on it. Nobody out there will be able to do it that quickly in any other format. These are 24-foot high panels, 8 feet wide, and they just literally went boom, 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 boom. This was in the middle of winter. It took us 3 weeks to put this together. This is a home in Invermere that we did completely from foundation all the way up through to the roof. So the reason it's up there is just to illustrate that we're not restricted in terms of design. It doesn't have to be a modern flat roof. It can be pretty much any type of design that you want. This particular home in Invermere is a duplex, 6,000 square feet, and they ended up getting an 87 EnerGuide rating off of this home. That should be it. Thank you very much. If you've got any questions, I think we're going to take those at the end.